And I'm preparing to live stream the Zoom API in the YouTube. Perfect. Perfect, perfect, perfect. Okay, so I'm at your service today. Of course, you know we have an exam. Let's do a couple of housekeeping chores. And we can see what's happening. So let me share my screen. You can see us here. We're ready to go. A bit of a delay, but that's okay. So let's do the what's due section, and we can see everything in line for the what's due. So today is the 16th. We don't have anything formal on the 16th due. On April 21st, which is Monday, we have, of course, an in-person exam. We followed the same formats as everything else. So I'm going to the exam 2 review guide just to make sure. On what's due is in PowerPoints and documents. And exam review guide. We'll go over it, but this is one of the things that I want to make sure that you realize, that it will take place in SBA 204 PC Lab Monday. The exam will be in person. It will be proctored. I want you to arrive. In this case, you can arrive 10 minutes early. The exam is closed note, closed book, closed AI software. The exam is entire period, but you can leave early. Don't forget your pictured ID. Don't forget to bring your laptop and respond as we always have issues. And these are the parts. It will be 2 parts, multiple choice and open-ended questions. There'll be 2 separate tests just like before. And you can think about it, the multiple choice questions. In the multiple choice questions, there will be many of the questions that will cover chapters 4 and 5, which talks about security, talks about risk, talks about threats, vulnerabilities, physical controls, access controls that we talked about before, virtual private network, HIPAA compliance being health insurance portability act, ransomware that they can do it. We're request Bitcoin again in risk. What do we want to do? We can't get risk to 0, but we need to get it lowered, or we can transfer the risk, or we can accept the risk. What does it mean, acceptance of the risk? It means, hey, I know that maybe someone can get to my PowerPoints, but I'll accept that risk that they got to my PowerPoints, right? It may be acceptance on something that is not so valuable to you, that you realize that it's acceptance or transference, that you go to an insurance, someone else takes the risk besides ourselves. And for instance, many organizations do this. The university, of course, we talked about the security issues, and of course, the university has insurance to transfer some of the risk, but they still have to do due diligence and follow some. Unintentional threats. Anna, what does unintentional threats mean? What's an example of an unintentional threat?
Can I look it up?
You can look it up while I ask somebody else, and we'll come back to you, of course. But unintentional, as you're looking it up, Anna, does it mean that you intended to be involved in intentional would mean what? Intentional means that it was on purpose, right? Unintentional means what, Anna? If I said
It was
intentional, I hurt your feelings, but it was unintentional. Or, somebody else could hurt your feelings, right? When you get an argument with someone, intentional, right? So an unintentional threat it's unbeknownst to possibly someone that's involved in the security threat. Have you ever heard of social engineering, Anna?
Yes.
Social engineering is what? Is when someone is basically, you become involved in the security breach, but it was unintentional on your part. So if I think about social engineering, that could be an unintentional threat. You were involved with it. I started schmoozing. I started saying, oh, Anna, you did so great in my class. You know what? Let's go out to lunch. And then I have Daniel there. And I said, oh, leave your computer on. Daniel will take care of it, you know? So that's unintentional. I social engineer, and then I have my friend Daniel come in and finish the job. So that's kind of on social engineering versus Anna. Deliberate threats is somebody that had the intention, right, to do harm to the university. So many times on those deliberate threats, when we were using a Duo, you remember we went to Microsoft Authenticator, everybody had to switch over. Nobody really said hooray, hooray, right? Nobody was saying to our security officer, hooray, hooray, we have Duo, right? But it's basically another way to do Duo. What? Why do they call it Duo? Is basically multi-factor authentication to basically reduce risk mitigation, right? So there's some types of software attacks you need to know, and there's charts in the books and all requiring a user action, those needing no user action. Also, what we talked about is business continuity. What does that mean, Anna? That if we get, for instance, a hurricane, if we get earthquake, if there's a fire, what should we do? There has to be strategies in case we have some kind of accident. There has to be strategies for business continuity. What does business continuity mean? It means that if the university gets hit with a hurricane, what's their business? Their business is to educate, right? Their business is to have a hospital. Their business is to do research. There has to be a way in which they can continue doing it. Sometimes they said, oh, we'll use Zoom. One of the problems with Zoom is what? Is that you have to have internet access, right? And Zoom has to be up. Notice my 3:30 class, Anna, I went in saying, oh, I'm going to meet my class, and Zoom is down for the entire university. So I have an issue there, right? So what should they have done? Is done a strategy for business continuity. And what could they have done? Daniel, what could they have done saying, if Zoom is down,
Yeah,
right?
then use Google Meets or something
Yeah,
like
use
that.
Google Meets or use Teams or whatever. And then I tried to get into Teams and I was with somebody on Blackboard. I said, oh, I'll do business continuity. And guess what? I couldn't get, all the students weren't registered. It clicked, enter class can be all my attendees. And guess what? I get an error message and I couldn't do it, right? So they should have that already prepared, right, Anna, for business continuity. If one service goes down, we have something else to replace it, right? And we talked about the difficulties of managing data. You remember data, and data government. What are the difficulties? The difficulties is what? We got too much. The difficulties is keeping track of the data. One of the things of the database approach is, and you're going to need to know this, is what you, in a database approach, some things we want to maximize and some things we want to minimize. For instance, redundancy. Isa, what's redundancy for a database management system? What are we doing with redundancy? Do we want to reduce it or maximize it? Reduce, right? We want to minimize, right? So why do we want to do it? Is we want to minimize that data base, and we want to make it that we don't want it to be siloed. What does siloed mean? It means that everybody can get access to it. So for instance, there may be some ideas where I have, Anna, what is your major?
Legal studies and business law.
Okay, so legal study. So they were looking, somebody wants to give an internship or with a scholarship to a female that's majoring in legal studies. What year are you, Anna?
I'm a freshman.
You're a freshman, right? And maybe from with certain interests. Sometimes it's too narrow. I don't have all that information. With a GPA, let's say, of over 3.5, Anna. So basically, do I have access to your GPA? No. But if we had a database approach and we could make a query, then people could have access. So that would be it. So it's a data file. You need to know about that. What is a column? Basically, like in a spreadsheet, a field, a row in a spreadsheet is a record. Cloud computing, you have you have articles about cloud computing. Plus you have chapter TG3 about cloud computing. And then we have 3 things here: IaaS, PaaS, SaaS. So we have infrastructure as a service, platform as a service, and software as a service. And then we have something called a public cloud, a private cloud, and a hybrid cloud. We need to know all of these. So if in this case, basically I could go and then I have sample open-ended questions. And with the open-ended questions before that, I have a number of articles there. So what would give me about cloud computing is I would want to look at, Anna, these 2 articles that tell me, one is from Amazon, one is from Microsoft. AWS is the cloud service called Amazon Web Services, and Azure is the cloud service for Microsoft. Okay? So let me do this. Let me move. In this case, stop sharing. So at one point, what would I want to do? I would want now to do, Anna, is figure out what is infrastructure as a service, what is platform as a service, what is software as a service. And if I think about it, Isa, what we all use in this class, I guarantee you, is what as a service. If I thought about infrastructure as a service, platform as a service, or software as a service, what would you say is the most popular service among the software? We all use it. Right now, Zoom is it. We now use Gmail. I use, in this case, any Instagram, any of those that I use personally, and you use personally, we use it as a group, a Word document, Excel. They're all software as a service when they do what? When I go onto the internet and I get the service. So you understand, Anna? As a service, you can put in your notes, as a service means we go to a browser through and we get it through the internet. When you came on, did you have to go through the internet? Yes. So all of a sudden, you know that all of those applications, all those apps are as a service. It's like secondhand to you. Very little do you use without the internet, right? Look at this, how we were running Zoom, all of a sudden had server problems. I don't know what the problem was, but the entire Miami.Zoom that we all use was down. And could the University of Miami, in this case, Isa, could the University of Miami fix that problem? You think? No, because what? They don't control the servers from Zoom. And I don't even know if Zoom controls their servers. They may give it to another party. They may even give it to Amazon, right? So it's the idea of control. The less control I have of all the computing parts is usually the software as a service. And what people want to do, you remember transference that we talked about in risk, Isa? People want to transfer a lot of the controls to others, to providers. Who are the providers? Google's a provider. Amazon is a provider. Microsoft is a provider. So if I share, let's see. So if I share my screen and go here, what does this say then? Isa, we're going to do this together. Okay, Isa, you there? So
Yes.
it's in this one, this is a great article. This has my cloud computing defined, that I know it's what? Delivering services. What are they? Servers, storage, database, networking, software, analytics over the internet. That over the internet is called the cloud. The types that I have, the benefits, these are the benefits. It's going to be basically helping me in costs because I'm going to share the costs. I don't have to hire a whole IT staff to take care of it, right? We can understand that. And the deployment methods, basically, the way the cloud is deployed is basically either they call it public, private, or hybrid cloud. Public means, and they call it clouds. Clouds, you can think about those servers where my services reside are owned by a third party. Have you ever heard of Isa, a server farm? Isa,
Yes.
a server farm, what is it? It's a big data center with maybe hundreds of thousands of computers running. Now, when you think about the AI, all these new AI and NVIDIA and all these other companies, what are they doing? They're going to be building all these server farms. And what's the problem with all these server farms? They're going to take what? He said they're going to take a lot of electricity. Are they going to take air conditioning? Yes. Are they
Yes.
going to basically going to have security? All of that is going to be for these big data centers. Now, I can do what I can call use a public cloud. And what is a public cloud? That my information and the software that I use resides on a server with other, let's say, with other people, with other institutions. So have you ever used Google Drive, Isa?
Yes, I have.
Okay, Google Drive is a public cloud. Your data's there on your drive, but it's not really a physical drive that you have somewhere. It's basically what they almost think about it as virtual. You have space on their server. Does it mean that it's completely unsecure? No. What does it mean? That you need still your own password to get into it? But people in that case of the public, it's managed the accounts through a web server. It does not mean it's not secure. It means that we're sharing the information. A private cloud, Isa, is one that I need more security. Let's say with the Department of Defense, or maybe I was even a bank with multi-billions of dollars. Maybe I would say, you know what, Amazon, provide me a private cloud. So my single business or my organization or the Department of Defense at the data center will have then be physically located that others are not sharing in the space. Do you understand, Isa? Yes, no,
Yes.
maybe. Okay. And a hybrid, what do you think is a combination? Some of my data is not that important that somebody grabs me versus some of the others that aren't. That's the hybrid. And then we have what we were talking before, we have types of services. And these types of services, we just looked at these three: infrastructure as a service, platform as a service, and software as a service. So if I start with software as a service, everybody knows this because everybody does this. Alexa, any software where you need to go to the internet to use is a software as a service. So if I asked you, Isa was looking for examples of what are software as a service, you could list tens and tens of those, of what you use. From Blackboard to Zoom to your social media to your emails, right? To a lot of your apps are software as a service. And basically, you can think about this is more control of the user as it goes down to less control and what it's for. So infrastructure as a service is basically a company that says we want to rent. And why is it rent? It's on demand. It's a cloud service infrastructure. And what does infrastructure include, Isa? Servers. Those are computers. That's a server that may be serving other clients or other people. Virtual machines, that means it's not physical, but on a computer, what we'll do is via software, it will act to the operating system like another computer. Why do they call it virtual? Because in this case, a virtual machine, for instance, if you have a Mac, you could create basically other software in your computer to make it a virtual, that machine or that computer runs in its own space within another computer. That's what it's virtual. Storage, you know what storage is, right? Storage is what? It's my hard drives everywhere. They're going to store my data, networks, how I can connect to my computers. Look at this operating system from a cloud provider is pay as you go. So it would be a company that says, you know what, we don't want to handle, we do computing, but we don't want to buy the hardware. And the basics that go with it, help me buy that hardware. That's what they call infrastructure as a service. Questions, Isa?
No, none. Thank you.
Okay. The second one where it was confusing is platform as a service. And what I said was like an operating system, but who uses a platform as a service is usually not the end user. Alexa's not going to go to Azure by herself and say, you know what, I want a platform as a service. Who is going to go there are people that develop software. So if Alexa was a CEO of a business and she says, you know what, we're going to basically create some software, we're going to create some AI apps, and she hires some programmers, they say, you know what, instead of, in this case, they may kind of say, instead of us using all our computers, they will say, basically, probably even advise Alexa and say, you know what, we can go to Amazon or to Microsoft and rent out a platform as a service that will give us an environment that will allow us to develop applications, test those applications, deliver those applications, and manage them. So it's basically, if she wanted to create web or mobile apps from the beginning, somebody wanted to create like a Wix, not like you do a little website, but you wanted to create a program to compete with Wix, Alexa, then they could do a platform of a service without worrying about managing the underlying structure of service storage networks and databases. So in the way, do you see how it's overlapping, that infrastructure as a service and platform as a service? This is more, in this case, for the programmer from beginning to end to finish their applications. And part of it is they're going to get an operating system. They'll get it almost like a bundle. And the third part is software as a service. It's the method then of delivering software applications over the internet, right? What we always said, on demand. What does on demand mean, Isa?
You can access it whenever and wherever you need it.
Whenever you need. It's almost like on demand, right? Every time, you now can see a movie on demand, right? You don't have to go to the movie theater at Wednesday at 7:00. You say, hey, I want to go out to dinner first. I want to eat. I just finished that class, right? That's on demand. And you're basically your subscription then, just like a subscription to Netflix, right? Right, is a software as a service anytime on demand. And basically, we have a cloud provider. Who is a cloud provider? Somebody like Amazon, a cloud provider, somebody like Microsoft, host. They basically will serve out, just like a host of a party. They will be your server and manage the software application, all your underlying infrastructure, handle any maintenance, do your upgrades and security patching. You want to take care of that? I don't want to take care of it. The university doesn't want to take care of it. So they say, hey, listen, basically on this software as a service, Zoom is supposed to be taking care of it. But guess what? Zoom had an issue. But guess what? We could have had an issue too at the university, right? Does the university's Wi-Fi ever go down? Have issues?
All the time.
See? So in this case, they couldn't blame the Zoom meltdown because of that. Their Zoom takes care of that infrastructure, but we still have to go through, if you're on campus, we still have to go through their network. And even if you're off the network, you can always still have Wi-Fi problems. So basically, you're handing off all this as a service. A business hands off the responsibilities to another provider because we don't have the skills, we don't have the time, we don't have the money to take care of it. We could, for instance, get a group of people to host Zoom. Rather than Zoom here, they could have had a room with a bunch of computers hosting the Zoom software. But they said, hey, how many times does Zoom go down? Not that many. How long did it go down? Well, it went down for a half hour, and big deal. The professor couldn't teach that day. The students will only just be happy not to see her face sometimes, right, Isa? So it's not, we always have to make that decision. How much is this going to be important, So you have to think about it. Users connect to that. And then you don't have to worry about servicelessness. But then basically they're talking about, here they're trying to compare yourself with Microsoft. Doesn't matter, but it's the same thing. If I go to AWS is basically what, Isa? It is a competitor. Doesn't matter. They all copy each other. And look what it says. Cloud computing is on-demand delivery of IT resources over the internet, pay as you go, instead of buying, owning, maintaining. The university said, we're happy to get out of that business. The university really now is even cutting down. It's basically, Daniel, remember I told you that they're going to move to Canvas?
Yeah.
I was at the computer advisory committee and they told me they're not so sure they're doing it so quickly. Because of what? If they change from Blackboard to Canvas, you think they're going to have more support? They're going to have to add more people? Or they're going to have more headaches?
Yep.
That's going to cost what? Money, right? Plus time. So they're not sure with some freezes and things with the university and the university budget, not knowing exactly what's going to be happening in the future. He's not sure. The head of the platforms team for learning management system told me he's waiting to hear if they're even having a budget, and then they may just delay it for a year. And maybe they'll just go to Ultra. I don't know. But those are kind of questions that people have. So who's using it? The benefits we know. You have to be agile. What does it mean? That you can move with the times, right? I can get more services, less service. What does elasticity mean? If this is the case, Tessa, have you ever heard of elasticity? What do you know about elasticity? What does it sound like? You know, I have elasticity. Do you have like your big pants and your small pants? Whenever I gain a couple of pounds, in the back of the closet, I have my bigger pants. Maybe it's with elastic. I don't know. But here it is with cloud computing. You don't have to basically, we don't have to order, Tessa. If we go into business together, Tessa, you know, in the beginning, how many customers do we have? 0. You know, whatever we did with the website, I'm excited. You're excited. I say, hey, let's go for business. I'm ready. I'll support you. I'll find our investors and we'll go for it. And then all of a sudden, and then you say to me, you know what? We got to buy a lot of computer hardware. We have to hire a lot of programmers. And I said, wait a minute, hold on. I don't want to over provision my resources. I don't even know if this business is going to work. And also, what's the problem with that, Tessa? We buy hardware today and then maybe we'll grow in 5 years. What's going to happen with that hardware? It's going to be worth nothing and it's not going to be good, right? And it's not going to be up to date. So what they call over provision, do you see that, Isa? Over provision your resources is basically a way to get the exact amount I want. I can scale up or I can shrink. So that's what it means, elasticity, just like elastic, just like a rubber band, right? Tessa, I can go out real quickly, but then I can go. When we got all those in the lab, did you see all those computers they have sitting around for you to do the test? Do they look brand new to you, Tessa?
No.
No, they look like old stuff, right? So on that idea here, so they're not going to be elastic that every year they don't want to buy new machines, right? But if a lot of it they can go over to the cloud, then they can use a lot of the hardware that's going to be more powerful, but they can use it. That's what it means, elastic. Cost savings. Why is it going to be cost saving? Because I basically, these data centers, these physical servers here, they're going to be variable expenses. You only pay for the IT that you use. That's why then buying and it's economy of scales. Do you know, Tessa, the most profitable subsidiary in Amazon Web Service is not selling to me and you. It's this, their cloud services. Can you imagine it? That's their most power. Even though we don't know them as such, that's their most profitable because what? They give us a small part, right? And it's economy of scales that they can charge us. And even if they charge us relatively a lot for them, it's going to be less for us. And deploy globally in minutes, types of cloud computing, infrastructure as a service. Do you see this? Basically, basic tools, right? Virtual or dedicated hardware, data storage gives you the highest level of flexibility and management control over your IT. So these are people that want to control their IT, but they want to rent it out. That's not me and you, Isa, right? But if we were in a bank or something like that, we may want to do that. Platform as a service, the need for you to manage it, platform, you don't need to manage this hardware anymore and this operating system. So if you have, Isa, if we have a programming team that we want to, let's write some apps with, our programmers don't want to worry about managing hardware. Our programmers don't want to worry about operating systems. They don't have to worry about buying the equipment. They don't have to worry about basically what they call the heavy lifting that involves running your application. All they're going to be worried about is let me write the software for us. And later on, more and more writing of software will be AI will take over. And then software as a service. And software as a service, this is where everybody has access to.
Professor.
Yes.
So could we say that AWS is a good example for the open-ended as infrastructure and platform as a service? Like it would be an example of both.
I can get all of it on AWS. But yes, if I wanted to go for infrastructure as a service, and it's this, let me see if I understand your comment. If we had a company, let's say we were consultants, somebody came to us and they say, we don't want to buy the hardware, right? We could say, go to AWS, and a lot of the startup companies do that. They go to AWS and they rent out the infrastructure. And then we could have all those startups, those AI startup guys. They say, we got our programmers, but we don't want to worry about the operating system and taking care of what it takes to put together their programming environment. They just want to program. They would then rent out platform as a service. Is that what you wanted to say?
Like, yeah, I was asking if this could be like AWS could be listed as an
Yes.
example of
Yes.
concrete evidence or concrete.
And they give out those services. So if I looked at it, which is interesting, if I look at their products, look at all their products, they have services, so many, right? They have so many that if you wanted, right, artificial intelligence, you wanted to do database, they can help you do that. If you wanted end user computing, if you wanted to write a mobile app, you could use their product to write a mobile app. So you wouldn't have to give your programmers hardware or an operating system. You could just say, go to AWS and rent it out. And if you need more memory, we'll just buy more. And when we need less memory, we'll just pay as we go. Just like electricity, right? When it's really hot, we turn on the air more often. Does that help, Isa? What else is not clear? So it's the same thing. So if I look at where we were talking about data, we talk about, you remember, Isa, have you ever heard of big data?
Yeah, last
What is
chapter.
the difference between real, just when they say data versus big data? What do you think? One is big and one is small.
Is it big data is just like a lot more data to handle?
Yeah,
like
think about the
millions of
stock.
data?
And what's a good example of big data? Think about the stock market, right? And let's say we wanted to be traders, right? And let's say, it's so volatile now, maybe we can make money or we can lose a lot of money with this volatility. And we wanted to invest in NVIDIA, right? Well, we could be what they call high frequency traders in our data NVIDIA. How often does their price change per day? Once a day, twice a day? What do you think? The price of, if we wanted to buy NVIDIA?
Lots of times a day.
It's like a basic milliseconds a day, right? You blink your eyes and the price has changed, right? So really billions of data points. That is called big data. When you have numerous data points and these big data systems perform, Isa, very well for predictions because they contain huge amounts of data. So they do well to base predictions on. If I have less data, I'm usually going to make a less good prediction than if I have lots of data. So big data systems then perform because they contain huge amounts of data on which to base their predictions. and then a data warehouse, and this is all on data, right? And so when I'm seeing it in real time, my data, right, to do my predictions, that's going to be real time. But later on, I want to do some analysis, and I'll take some of my data to do some hypothetical research studies. I'm going to store it in a data warehouse. Just like in marketing. Have you ever taken a marketing class, Isa?
Yeah.
So in a marketing class, they have a lot of marketing data, right? On consumers, how they like the products, on how well certain campaigns went. All of that data goes into a data warehouse, and it's then historical or real time, Isa? Historical, because we're storing it to make studies about it. It's almost like hypothesis testing, to make studies about it. And we store it there so we can make it. And it's what we call in a data warehouse, is the data volatile or non-volatile?
Non-volatile.
Look at that. You're on a roll. So the data then is non-volatile. It doesn't change. And you know there that it doesn't change. So my users aren't sitting there and changing the data. What they are doing is they're manipulating it and looking at it and analyzing it and setting it up by, maybe we have a data warehouse of student data. And we may define it by schools or by departments or by the years. And then we create what we call a data mart. The data marts are like mini data warehouses on a certain subject. So maybe it's business school. I'm going to put it in there, and I may have it for the BTE department or the finance department, and do data on that. And then we have what we talked about it last time, right? In this case, Heidi, were you here last time? I think so.
Yeah.
So you remember we talked about business analytics. We talked about the idea of descriptive, predictive, and descriptive, predictive, and prescriptive.
Mm-hmm.
Okay, what was past data?
Descriptive.
Descriptive. What does descriptive mean? Is that I can describe, right? I can get the average score of our tests, of our first test. That's descriptive statistics, right? You can go to your grade book, Heidi, and look at what was your average, what was your score on the test, right? You can look at that. And then if Daniel had to do a curve, right? He curved the scores. He did it based on the past, how people had done. Now, what we could do is predictive. Predictive means what then, Heidi? The past or the future or the present? Future. Do we know what's going to happen in the future? Of course not. But if the more data we have, right, Isa? The more data we have, it may help us be better in our predictions. Right? So the idea, why do they send me out, Heidi, these notes to let people know if they're up to the midterm, if they haven't been doing well in my class? Why do they send it out? And they want me to alert the advisors, because they think the past may predict the future. And they want our students to do well, right? The advisors, the university, they don't want to take students. You're an investment for them, right? Heidi, when they accept you, it's almost like it's a two-way street. We have to take care of you too, Heidi, to make sure you do well. Right? We want you to succeed, not only in the classes and at the university and be happy, but also to succeed after you finish. So these are in predictive. And Alexa, what then is prescriptive mean? we have an idea of what's going to happen, but then what? We have a couple of students in this class that haven't done well. We can predict that they're not going to do so well, right? But we want to worry about it. So what do we do? We give a prescriptive, but what should we do? Maybe we should get them a tutor. Maybe we should have other peers in the class help them. Maybe we should, for those, the prescription is they should see the TA more often. Maybe they should spend time after the class or whatever. Maybe have them use Notebook LM more. I don't know. But those are what? Prescriptive ways. And then we have in neural nets and in artificial intelligence, we have something of supervised and unsupervised training. Is that supervised is more with humans trained these neural nets and machine learning. And unsupervised is we give it the data and then say, you know what? Go learn on your own. And then we talked about generative AI and AI subfields. And this can also help. This was in the readings and this also in these articles. What else do I want? And these are the questions that I'd like you, what I think you do, Dylan, Henry, in order to do well. When people say, how could I do well? If you research this and know the answers, then on the open-ended, you'll be able to answer it. Like even today we did it. What is cloud computing, right? Henry, explain 4 benefits, give 3 business usage examples, name 2 disadvantages. How is cloud computing used in your assignments and projects, right? So did I answer your question, Isa?
Yes, thank you so much.
And what else do I need to go over?
Could you talk about the Gen AI, like the difference between Gen AI and the machine learning?
Okay, so basically, generative AI, the main aspect is generative AI come up with something new. Isa.
Yes, sorry.
Yeah. So when you think about it, in generative AI, we're talking about it. In this case, we're talking about generating something new, like even an image, right? Tessa, have you ever used it? Yeah, for pictures. It's coming up with something we didn't even say. In terms of, remember we got the guys for music. Were you here, Alexa, for the guys that did the music? That song didn't even exist. So Gen AI was good in coming up with something, generating new. Machine learning, what that is very good, it's a machine, meaning a computer, and it has a difference from traditional computing is that it will learn, meaning that you train the system. And what it really is the best at is recognizing patterns and relationships with machine learning. So how does machine learning work? So let's think of an example. I didn't know if you know that, but not only am I a professor in the business technology department, but I'm also a professor in health informatics, and I work with the medical school. In what? I'm not a physician, but I work with them in data. What? Big data and machine learning. So I'm working with radiologists. What do radiologists do, Isa? People look at what? And for instance, I'm especially looking at women that get mammograms. And when women get mammograms, basically, why are they getting mammograms? Why are they suffering through that? Most of you are too young to get a mammogram, but what they do, it's not a comfortable position to get. Your mothers and grandmothers, all of you, hopefully are getting mammograms. And what they do is they're looking for what? They're looking for something unusual, some cancer. And hopefully if they get it in the beginning, right, Isa, that you have a better chance of surviving. A trained eye, when I look at X-ray, to me, I don't know what I see. I see some dots, I see some things, but I don't have a trained eye. Somebody could train me, and after a while, I could be trained as a radiologist, and I could get better at finding what? A pattern of what maybe breast cancer is. Or I could think about your skin. If I have some kind of freckle here or something like that. Now, what can I do is I can take my phone, right, and take a picture of it and ask Meta or ask ChatGPT, or what do you think it is? People that are trained on it. I go to I also work with dermatology, and I go to my own dermatologist, and I have something, I'm light skinned, so I have something on my forearm. I say, which I'm not a dermatologist, but I pretend to be one, right? I'm always having self-confidence. I tell him, actually, I think this is cancer. And he comes back to me and he says, no, it isn't. And I say, how do you know? I've seen what? Hundreds of this, and this is not cancer. This is some other, precancerous, from sun problems. He knows it. Why? Because he's seen it many, many times. So what do you do in machine learning, Isa? Is you have somebody like the dermatologist work and feed it scans of those that were malignant and feed it scans of those pictures that were not malignant. And you put them in two piles in machine learning, and you say, this pile right here are malignant cancer. This pile here is non-malignant. Me as a layperson, I think they all look kind of the same. But a trained dermatologist for many years knows the difference. But once you train the machine to do it, the machine gets really better and better. And then when it makes mistakes, you said, oh no, that's not, put that in the pile of basically the cancer ones, or put those that are the malignant ones. Put that picture in the non-malignant. And after a while, it can find little abnormalities that as a human, especially a beginning, let's say radiologist or a beginning dermatologist, would not be able to do. You understand that? They're not making up stuff. That's what I love, generative AI stuff. Let's make up a business strategy, Isa, because we really can have a little bit of what I call hallucinations, make it up. But in terms of being exact in medicine, they're using not generative AI for that, but they're using machine learning. And they're training it to find what? Patterns and relationships. The generative AI is great because it's kind of like, it doesn't even know what we're saying, but it's good, for writing stories, even correcting. We start off with, even many of you use it, I use it, you start off with an email, let it expand upon it, let it try to be looking more friendly. I have this tendency, I want to get down to the point, and maybe my empathy doesn't come through, whatever it is. Start doing little tasks. Does that help, Isa?
Yeah, thank you so much.
Okay, what else from anyone else? It's open-ended. Mark, how we doing?
Doing good. How are you?
Okay. You have any questions for me?
Oh, no. I should
Okay.
start studying. And
Yeah,
hopefully
so
we'll
that's
be
it,
good.
but I would do like all those other things. You have everything in the pages, you know what I mean?
Yeah,
And then the open-ended, they're not gonna be any surprises. That's the good part, you know what I mean? You can't say, oh my goodness, what could she possibly ask me, you know? There's so
yeah,
much going
perfect.
on, you know what I mean?
Mhm.
So I know the questions that she's gonna ask me, the open-ended. And the other ones, if I know those terms, about those terms, that should be good too. Right? And you took the test before, you know what I mean? So you know what it's like, you know, so you don't have to worry about that. I know where it is, I know how to take it. Okay, what else do we need? I need to share one more thing with you. Is under what's due, right? Is this available to me? It's off, right?
Yeah, it's for
Is
students.
what else do I need, Daniel?
Yeah, just that second to last assignment, the assignment's 10.
Okay, assignment 10. And when's that due? Oh, that's after that's when you're gonna present to me.
Yes.
So I wouldn't bother that. So basically, when you think about it, after you take the test, in this case, Alexa, what you'll have to do is then prepare to the following Monday, present in class. And this gives you the instructions on what to present to the class. And then after that, and then you have one more, right, Daniel?
Yeah, there's one more part after that, which is a recorded presentation and then a peer review.
And the peer review.
And it's very important with the peer review. It could count against your grade if it's dishonest. And it probably will count against people who didn't do enough. So you have to be very descriptive as to what you did and what your team members did in the peer
Yeah.
review.
Okay, which makes sense, you know, but hopefully we won't have that issue, right, Emerson? We'll go through it, and we got something to be proud of, and then we'll go through it. On the day after the session, after the exam, I'll spend time with you of what everything else is due for the end of the semester. I'll spend time with that. I'll look at your projects. I'll look at what your assignment should be, what everything should be done. So there's not going to be, it'll just be the project. That's why we're doing it. Okay. So the attendance, if you can, I'll just do that. The attendance. Let's do check-in. Start checking. We'll get some number. 5415. If you can be so kind and put that in the chat. 5415. And hopefully this helped. Thank you for coming. Thank you for being with me. Have a great evening. We'll see each other in person Monday.
Thank
Stay with
you.
me if you have any questions. Okay. Thank you, Tessa, for moderating. Thank you, Isa, for your great questions. And being such a conscientious student.
Thank you.
You're welcome. Okay, so let's deal with everyone else here. So Daniel, I'll deal with you in a moment. Avery, what's up?
After class on Monday, we talked about working through the fast bots. I was just told to stay after on Wednesday, and
Okay,
then I
so did you
think
get
Daniel
it?
was gonna
Is it
work.
working?
No, I'm still really struggling with it.
Okay,
I
so
can do a
maybe
breakout.
Daniel, let me just promote you.
Sure.
And let's just hear what anyone else has. And we'll make it work. Okay, Avery.
Also,
yeah.
I forgot to put in the attendance code on Monday, so I was marked
Okay,
absent
so
for that as well.
Daniel will take care of that as well for
I'll
me,
fix
Okay.
right? I appreciate it. I don't mean to be, Daniel will take care of that.
That's
You
fine.
know, you got me in the right frame, right, Daniel? I
Yeah.
don't want to come off as being rude. Okay, so Sophia, how can I help you, my dear?
Hi, Professor. I hope
Hi.
everything is well. I wanted to discuss exam 2 with you. I
Okay,
am observing Easter with my family
yeah.
over the weekend.
Well, okay, let's talk about that. Let me finish with everybody. And we also want to stop recording, right, you guys?